Good day, everyone. Welcome back to Learning to Understand Digital Electronics. Today we'll be covering K-maps. So what is a K-map? K-maps are basically ways that we can simplify a long expression down to its most basic combination of gates. So we have two types of expressions we normally have. We have a SOP and a POS. Now, what do these mean? Well, a SOP is a sum of products. It's a sum of products. Now, a POS is a product of sums. So we're going to get into the SOP a bit later, but let's start off with the POS. Product of sums. So let's take a look at an example. Let's say we have something like we have Y, which is our output, and we have A plus, well, A plus B plus C, and we're going to times that by, let's say, A inverse plus B inverse plus C, and we're going to say A plus B inverse plus C. And let's do 5 expressions because I think that should be reasonably complicated without going too far. So A plus B plus C, and then let's say A inverse plus B plus C inverse. And then let's say A plus B inverse plus C. So what do you notice about that? We have all these groups. We have 1, 2, 3, 4, 5 groups, all multiplying each other. And each of these groups are made up of pluses. So what these groups are, is they are OR gates. This is an OR gate, this is an OR gate. And you notice we have our pluses, which make up the OR gates. And then, so these are all OR gates. And then we combine these OR gates into one AND gate. So if I were to actually draw this now, if I were to draw this, I would end up with an OR gate that is 3 inputs. This is our first OR gate. And I'm going to take this down here. This is A, B, and C. And I'm going to have another OR gate. And this A is going to come down here. This B is going to come down here. Oh, sorry, this A is going to have an inverse symbol in the back because we are inverting it before it goes into the gate. So that little symbol means we're inverting it before it goes into the gate. This is an output, this is an output. And then here's another OR gate. I'm still going to take this A. This A is just going to go in. This B is going to be inverted. And this C is just going to go in. So this is invert, this is invert. And then let's just take these down a bit. It's going to have an output. Maybe delete that one so we have more space. Make it a bit bigger. So now this is the fourth one. So the A gets inverted, B goes in, and then C gets inverted. And then finally, we're going to have our A go in. A remains the same. Whoop. B gets inverted. And C remains the same. And then all of these are going to come together. Actually, I'm going to go like this. So all of these come together and they join in one big AND gate. So these are all OR gates. This is an AND gate. And you notice this is our A plus B plus C. This has the input of A inverse plus B inverse plus C. This has the A plus B inverse. Oh, I realized I put this is supposed to be C inverse, my bad. So I'm going to go back down here and I'm going to change that so this will be an invert. This is A plus B inverse plus C. And this is going to be A inverse plus B plus C inverse. You see that's inverted. And then this is going to be A plus B inverse plus C. And then when we add all of these together, we're going to get our Y. Well, not when we add, but when we multiply all of these together, we're going to get our Y. Now a K-map is a way of putting all these into a diagram and then being able to take out our result. So for a K-map, we're going to draw a box. And in this case, we're working with 3 variables, so we're going to draw a box like this. Now, if you're working with 2 variables or 4 variables, whatever. So we are going to divide this side into 4. Yeah, 1, 2, 3, 4. We're going to divide this side into 2. So this is going to be our AB side. And this is going to be our C side. And then we're going to go along in what we call grayscale. It's sort of like binary, but not quite. So this is going to be 0 and 0. This is going to be 0, 1, and then this is going to be 1, 1. Notice this is not 1, 0, because grayscale, only 1 digit is allowed to change at a time. So here, this digit changes to this. If we went to this 1 would turn to a 0, and this 0 would turn to a 1, which isn't allowed, because we have to have only 1 digit change at a time. and then this is 1, 0. Now for C, we'll have a 0, and we'll have a 1. So now what we're going to do is we're going to fill this table in with 1s and 0s. But how do we figure out what's going to be 1 and what's going to be 0? Well, we need to look at our formula. Now I'm going to delete this. If you remember back to when we were right, if you remember back to our first video on logic gates, you will remember that I said when we're dealing with an AND gate, we don't look for the 1s, we always look to see if anything is equal to 0. Because the second one of these lines is 0, we'll get an output of 0. The second any line is equal to 0. So how this is going to work is we're going to take a look at all of these expressions. Let's start with the AB. A plus B plus C. Now we're going to look at all the things that satisfy this. So what we're going to try and do is we're going to try and find a way to make this expression equal 0, so that this will give an output of 0. And we'll get to that why in a bit, but let's first see. So for this to be 0, all three of the digits have to be 0. So 0, 0, and 0. That will allow this to be satisfied by, that means for this to equal to 0, for this to equal 0, A must be 0, B must be 0, and C must be 0. So we're going to look for what digits would give an output of 0 here. Now for A inverse, plus B inverse plus C, we also want to make this equal to 0. So to do that, we're going to need to find what values will make it. Now, this will be 1, 1, and 0. Because when A is 1, then A inverse will be 0. And now just as a quick aside, if I were to say that, let's say, there's no C in this equation, well then the possibilities that we'd have to put in is 1, 1, and 1. So now these two equations will satisfy this is equal to 0. Because both of these values will now give a value that is equal to 0 when we plug it in. I'm not sure if I made myself quite clear. So when I plug in 1 and 1 in B and A, that'll give me 0. But then we still have a C variable, so this still needs to be 3 digits. So this will work when C is 0 and when C is 1. But for now, I'm going to plus C. So then this will only work with this specific combination now. And then when A plus B inverse plus C, well, that's going to be when A is 0, B is 1, and C is 0. See, it must add up to 0. And when A inverse plus B inverse, plus B plus C inverse, well, that's going to be 1, 0, 1. And then A plus B inverse plus C inverse. Let me maybe erase that and put it up here. So now that's going to be 0, 1, 1. Now we have all these combinations of digits. Now what do we do with them? So every combination you get when you make all of these equal to 0. We're going to now transfer them onto this table. And everywhere we see this combination, so when we see 0, 0, we're going to put a 0. We're going to put a 0 in. 1, 1, 0. So this is 1, 1, because this is our A value and our B value. A is 1, B is 1, and then C is 0. So this is B here. Then when A is 0, B is 1, and C is 0, then that's here. Then when A inverse, so when A is 1, B is 0, and C is 1. So when A is 1, B is 0, and then C is 1, we'll get a 0 there. Then when A is 0, B is 1, and C is 1, we'll get a 0 there. We have our zeros in our table. We're going to put in our 1s. Now, what this table essentially represents, these are our conditions. So whenever any of these values, whenever we get any of these values for A, B, or C, one of these lines are going to equal to 0. One of these lines will end up equaling to 0. And when one line equals 0, we get a 0 output. So that's why we're going to make these all equal to 0, and then we plug these zeros on. So this table basically represents what this is supposed to look like. So we normally express these now as POS expressions. No, sorry, as SOP expressions, sum of products. So with the SOP expression, we look at the 1, and then we get 0, 0, 1. And now a SOP is a sum of products. So our product is going to be A, B, and C. And now because this expression must equal 1, the only way for it to equal 1 is if both of these are inverted. And then for here, this is also got to equal 1. So this is 1, 1, 1. And the only way for that to be equal is if A, B, and C. Because remember, these are both AND gates. So only one condition will satisfy them being 1. And then this is going to be 1, 0. Whoop. This is going to be 1, 0, 0. So this is going to be A, B inverse, C inverse. But when I add these all together, my final expression will be Y is equal to A, B inverse, C inverse, plus A, B, C, plus ABC plus A inverse, B inverse, C. So this is now going to be our simplest expression. This is going to be 3 AND gates combined as an OR gate. And this is a SOP expression, sum of products. So this is, we are adding products. Now I want you to draw attention to something. Let's say I have, let's say this is now also equal to 1. So let's say this is also equal to 1. Of course, not for this example, but let's say it is. Well, now we'll group it in 2s. And we'll group this along this way and a wrap around here. Why do we wrap it around? Well, look at the difference. This is 1 digit away from that, so we can wrap this around. And this becomes a group of 2 and a group of 2. Now that means 2 situations satisfy this. 0, 0, 0, and 0, 0, 1. which means that C can be any number here. That means we're going to have A inverse and B inverse. So that means now we can simplify this down to one gate that has two inputs instead of three. And for this one, well, now 0, 0, 0 and 1, 0, 0 satisfies this input. So now C is not changing, so we'll have a C, and since we want that to be 1, it's going to be inverse, and since B is not changing, that's going to be there. But now you notice A changes, so A can be 0 or 1, which means this is not dependent on A. And now, of course, you get more complicated things where sometimes instead you'll have one that has, let's say, 4. Now, if the max for 3 things is you'll have 4 outputs. So, let's say, let's look at this now. Let's say this is 1, this is 1, this is 1, this is 1, and this is 1. Now we're going to group this around here and around here. So this becomes 0, 0, 0, and this becomes 0, 0, 1. So we immediately know the C's changing between these terms. And then we know, okay, 1, 0, 0, 1, 0, 0. So A is changing as well now. And now we're going to get 1, 0, 1. So we've seen that A changes and we've seen that C changes. So now we know this is just going to be B inverse. And then you would just add that here. And now this would become a group of 2. Now, the main goal, which I maybe should have started this off with, the main goal is to create as many groups, as few groups as possible. So you're going to only work in powers of 2. So 2 to the 0, 2 to the 2, 2 to the 1, 2 to the 2. So if we have 1 by itself with no neighbors right next to it or across like this, then it's going to be by itself and we're going to group it like that. If we have a group of 2, well then we're going to end up, then we're going to have group them in, if we have 2 next to each other, then we're going to group them together. And then they're going to be they're not going to rely on one of these variables. If you have 4, you're going to group that 4 together. And you're not going to group, I'm not going to like say, oh, well, there's these 2 together as well. No, no, no. It's just going to be this group of 4. But sometimes if you have a 1 and a 1 like this, but you notice this one isn't in this group of 4. So that's why I can group it like this. And we're never going to group in 3s or 5s. It's only going to be in powers of 2. Now, we've just essentially written, well, when we went back to our original K-map, the original one, the one that satisfied for this, we essentially used this little line here to simplify down from 6 gates to 4. 3 gates to go 3 AND gates and 1 OR gate. And now, if you want to try your luck, and you want to see if you understand the previous lesson on Boolean, then you can try and simplify down this entire expression into this. And if you somehow get a simpler expression from this than this, you did something wrong either in your calculation or in your K-map. Now, just as one last example, let's start off with a sum of products. So for this one, let's call this x, and x is going to be equal to a plus b plus a inverse b c plus b, let's call this a b c inverse plus b c b inverse. Yeah, let's call it b inverse. Now, as you're aware, I could draw it, but also you could draw it yourself. It's basically going to be something very similar to this, except the AND gates are going to be here, and they're going to be going into an OR gate. Now, the one thing I want you to bring your attention to is we're going to have an AND gate. We're going to have an OR gate at the end instead of an AND gate. And now, unlike the AND, the OR, all of these lines, these first 4 lines could all be 0. If this last line is 1, well then the output's going to be 1. Unlike an AND gate where these 4 lines could be 1 and that last line is 0. So the second we get a 1 in any of these expressions, we are going to get a 1 output. So what we're going to do is, instead of looking at what values would give us 0, we're going to look at what values would give us 1. So for this, if A is 1 and B is 1, and now since there's no C, then C can be any number. So that means these two values will give us 1. And now if A is 0, let me just put a dividing line. So if A is 0, B is 1, and C is 1. Now what happens if A is 1, and this is 0, and this is 0? Actually, you know what? Let's take this thing off B because I want to show you something. And now if this is going to be, A could be any number because it's not there, and B is going to be 1, and C is going to be 1. And then A could be the... Now you notice we have two values that are the exact same. What does this mean? Well, it really only means that if we go back up here and we pretend that these are all AND gates again, and that we'll just have 2 outputs that are 1. 2 of our 4 outputs will be the value of 1, which means we're still going to get an output of 1. So this in reality does not change what actually happens here. So this doesn't actually change what happens here. And also notice that this and this are the same. Whoop. This and this are the same. So instead of having 6 outputs that are unique, we only have 4 unique outputs. So we're going to put this on our K-map. And now, of course, if we have a K-map of like 4 variables or 2 variables, we're just going to have different lengths of each thing. So, like, if I had 4 variables, then I would have 2 of these stuck together. So I'd have 2 more rows down here. This is our A row, this is our B row, this is our C. So now this will be 0, 0, 0, 1. Remember, this is going to be 1, 1, and this is going to be 1, 0. I don't actually fully know why it's different, why we have to put the 1 there. I think it's to do with something with this is how the grouping can be optimized, because if we just go normal binary, then the grouping will be slightly different and it won't really work. But if you are interested in that, you can look it up for yourself. and I would love to actually know why that works. So now we're going to fill in our values of 1 instead, because remember, up when we were looking at our pos expression, we were looking for values that would give us 0, and we plugged in 0 on the table. Now we're looking for values that give us 1. So what values are going to give us 1? Well, 1, 1, 0, 1, 1, and 0. Then we're going to get 0, 1, 1, 0, 1, and 1. Then we're going to get 1, 0, 0, 1, 0, 0, which is this. And then, oh, then I forgot, we're also going to have 1, 1, 1. And then this and this are the same. This is going to be 0, 0, 0, 0. Now, we're going to group like this. And you might think, oh yeah, why don't we just put a third group here? Well, you notice that if we did do that, all the digits would be in groups already. So that would just be an unnecessary grouping, because we're trying to cover as many digits, all of the digits with as few groups. So, well, what group would this be? This would be a group of 1, 1, 0, and 1, 0, 0. You notice the value of B changes, so this will be A, and then C inverse, because the C is 0. And then we're going to say, well, this is going to be 1, 1, 0, and this is going to be 1, oh, it's going to be 0, 1, 1. This is going to be 0, 1, 1. Oh, also, I made a mistake. My bad. This is going to be 0, 0, 1. So you notice A is changing here, but B and C remain the same. So our final expression is X is equal to AC, A inverse C plus BC. And you notice we got down this expression that had 5 different gates and all these combinations. You can imagine actually having to build this. This would be a nightmare. But just by using K-maps, by plotting them on a graph, figuring out when there'll be 1, when there'll be 0, then we can group these together, and then we can get a simple output of 3 gates, and each of the initial gates only have 2 inputs. So it's actually quite nice. And some much better solution. And that's basically all you need to know when you're understanding K-maps. Thank you for your time.